So permutations and combinations are different from probabilities. They are incorporated when you get into more difficult probabilities. You do have to consider combinations and permutations. But right now, and what we want to do in this section is figure out how many possible ways can this happen. We're not asking the probability anymore. I don't want to know what's the probability of this happening. I just want to know how many ways can this happen. And one of the things that we have to decide is, does order matter? So there are a couple of ways that you can look at this. One is a counting method. So we could set up this little tree diagram. We've got a meals. Chelsea's deciding to prepare a meal. She has 3 meats to choose from, 2 starches to choose from, 3 vegetables, and 3 desserts. So let me just kind of show you what this could look like on a tree diagram. So she has 3 meats to choose from. Right? And then from there, she can choose, once she chooses a meat, she could choose 2 starches here. She could choose 2 starches here. She could choose 2 starches here. So you can already see this is going to get ugly, because then from there, she's got starch, starch, right? Starch, starch. So if she picks this branch, then she can go 3 directions here, or 3 directions here, 3 here, 3 here, 3 here, and 3 here. And then from there, she can break off and choose her 3 desserts, right, from each of those different things. So you can see how this could get really big and ugly. Well, there's an easier way to do this counting method. So say we have these things happening, and she's choosing several different events, right? So she's choosing from meats, and she's choosing from starches, and she's choosing from vegetables, and she's choosing from desserts. Meat, starches, vegetables, and desserts. Well, how many meats does she have to choose from? 3. So she's choosing 1 meat from 3 meats. She's choosing 1 starch from 2 starches. She's choosing 1 vegetable from 3 vegetables. And she's choosing 1 dessert from 3 desserts. So, in this case, what you would do is you would multiply. You have these multiple situations, just like when you have multiple situations with probability. You multiply them. You do the same thing here. So I'm going to multiply these together. 3 times 2 times 3 times 3 means that there are 54 options of how she can put these meals together. Okay, so that is called the counting method. We're choosing you're choosing 1 thing from each of those different events. So we can have that many things happen. So let's talk about permutations and combinations. So say we have a fruit salad. It's made up of apples and grapes and bananas. We don't care. It could be bananas, grapes, and apples, bananas. It doesn't matter. It's all the same fruit salad. Okay, so when order doesn't matter. Okay, if you don't care what order you put them in, you don't care what order you pick them in, what order you place them in, then it is called a combination. Okay, order doesn't matter for a combination. You can think of this in terms of you're voting in an election and you're voting for representatives. Order doesn't matter. You're just having 3 freshman representatives, 3 sophomore representatives. And so whatever they are, it doesn't matter. They're just representatives, okay? But you don't care what order they're picked in. Nobody's first, nobody's second, nobody's third. Okay, then you have this other thing, which is kind of confusing because it's the combination to a safe, but the combination to a safe is not actually, it's not created by combinations. It's created by what we call a permutation. So technically, we should have permutation locks, not combination locks, because it obviously does matter what order you put the numbers in, what order you put your phone code in matters. What order you dial a phone number in matters. Those are called permutations. Now, there are 2 kinds of permutations. One where repetition is allowed. For instance, how many different 3-digit combinations can be made for a safe? Think about, like, for your phone code. How many, if you have a 4-digit phone code, how many 4-digit codes could you come up with if you can repeat the numbers? So 0000 would work. Let's do a 3-digit combination. This is basically what we were just doing with counting. We can repeat here, okay? So we have 3 different digits, and I can choose there 0 through 9. There are 10 possible numbers to choose from. Since I can repeat the numbers, then I still have 10 that I can choose from, and I still have 10 that I can choose from. I'm going to multiply those together. 10 times 10 times 10 is 1,000. 1,000. So there are 1,000 different three-digit combinations that you can use for if you can repeat the numbers on the combination. Okay, so question, how many different phone numbers can you have? Well, over the years that I have seen, we have added more and more area codes. The reason is because we're running out of numbers. Well, how many numbers do we have? Assuming that there are no other rules, most phone numbers have 7 digits. So assuming that there are no rules as to what can be included, and typically that first number is not supposed to be a 0 or a 1. But right now we'll just go with no restrictions. So there are 10 numbers that I can choose from, and assuming that my phone number can be the same number all the way across, then it would be 10, 10, 10, 10, 10, and 10 that we can choose from. Like I said, normally there is a restriction on that first number, but for ease, we're not going to do that. So that would be 10 to the 7th, or a 1 with 7 zeros. 1, 2, 3, 4, 5, 6, 7. So there are 10 million different phone numbers that we can have with a 972 area code number, which is why we've had to go in and add with cell numbers and fax numbers and all these other numbers. That's why we've had to go in and add additional area codes. So what happens if it can't be repeated? Let's look back at this one that we just did with the combinations. What if it can't be repeated? How does it change? Well, okay, no repeat. Let me make this note here so we don't get confused. No repeat. Well, if it can't be repeated, then I have 10 numbers to choose from for my first number. Once I choose that first number, I can't use that number again. So now I have 9 numbers to choose from. And then I have 8 numbers to choose from. So what difference does this make in the number of options that we have? Well, now we have 10 times 9 times 8. There are 720. So when you can't repeat numbers, now there are only 720 options. It's a little bit easier to hack. Not quite. I mean, it's still not easy, but it is easier than having 1,000. So it is good when you can repeat your numbers. So let's look. We've got 3 people running a race. It doesn't matter. You can't be first and second. So order does matter. How you pick people, you can't reuse people. Okay, so order does matter. So we're going to line up 6 pool balls. So I'm going to put them in a row, and I've got 6 different pool balls that I can put. So after we choose number 4, you can't choose again, right? Once you put a number in. So I have 6 balls to choose from. And then once I choose 1, then I have 5, and then I have 4, and then I have 3, and then I have 2, and then I have 1. Think of like playing a pickup game, and once you pick a player, you can't pick them again. So this is actually called something mathematically. This is called 6 factorial. If you go from 6 all the way to 1, or 5, 4, 3, 2, 1, or 3, 2, 1. Anything where you go from the number all the way down to 1 and you're multiplying, it's called a factorial. That's on your calculator. There's actually a button. If you go to math and then go over to probability, there's actually a factorial button. Well, 6 times 5 times 4 times 3 times 2 times 1 is 720. So what this does is it takes out those repetitions, right? Because if order matters, right, for a permutation, order matters, then 1, 2, 3 matters and is completely different than 3, 2, 1. Whereas if you're picking 3, like in number 5, this example number 5, if I was picking 3, 2, 1, and it was an order didn't matter, I didn't care what order I picked them in, then 3, 2, 1, 1, 2, 3, 2, 1, 3, 3, 1, 2, all of those would be repetitious. And so you would pull out those repetitions. Okay, so order has to matter. Once we pull it out, then it can't be used again. Now, what if we only select 3? What difference does it make? Well, now I have 3 choices to make. There are 6 balls at first, then I choose 1. There are 5 to choose from, then there are 3 to choose from. Well, 6 times 5 times 3, nope, not 3, 4. I can't count. 6, 5, 4. You multiply them together. So 6 times 5 is 30, times 4 is 120. So choosing 3 balls from the 6 balls is 120. Now, there's a shortcut to do this. As long as there's no repetition, there is a shortcut, and there are 2 buttons that you use on your calculator. Okay, one is a permutation button. It's under the math menu, permutation, and one is a combination. Remember, permutation order matters. and combination order doesn't. Okay, again, order matters. You're choosing a president, a vice president, and a secretary. Order doesn't matter. You're choosing 3 class reps. Okay, that's how you can kind of keep up with it. So again, there can't be any repetition. So when you have repetition, the only thing you can do is like this, the counting method. That's the only thing that works when you have repetition. So we have 18 students in a class. How many ways can we line 6 people up for a photo? Well, once we've put a person in the line, we can't use them again, obviously. And so this is a permutation, and there is no repetition. So here's what you would do. So NPR means this: N items chosen R at a time, running it through a permutation calculation. So you're going to let the calculator do the work for you. Okay, so the way that you would type that in is you would say 18, and then you would hit math if you're doing it on your calculator. Go over to probability and go down and hit permutation, which is number 2. And it would give you NPR, so then you would type in 18 and then arrow over, and then you would put 6 people at a time. So we have 18 students and we're choosing them 6 at a time. And so if you type that in, then you're going to get 13,366,80 different ways that you can line up those 6 people. That you can line up 6 people out of 18 people. So how many ways can you put 7 bookshelves on a shelf? Well, we're gonna choose 7. We have 7, and we're gonna choose 7. Okay, and once you've used it, you can't use it again. So it's 7. Choose 7. So when you put that down, you get 5,040 as how many ways you can put those 7 books on a shelf. That's also 7 factorial, by the way. Now, combination, remember order doesn't matter, but it's the same thing. It's just a different button that you're going to hit on the calculator. So we have 64 golfers participating in a golf tournament. You're going to create teams of 4. How many groups of 4 golfers are possible? Now, what this is going to do is pull out all of the duplicates, right? And where maybe you chose this person, maybe you're the same 4 people, but you're chosen in a different order. Since order doesn't matter, we're going to pull out all those duplicates. So your combinations are always going to be less. So we would choose, we've got 64, and we're running it through a combination, and we're choosing them 4 at a time. And when you're doing that, you get 635,376 different combinations of ways to choose people. How many groups of 4 you can get, pulling out distinctly different groups of 4. Okay. You order a sandwich at a restaurant. So, and you're choosing 2 side dishes from a list of 8. So I have 8 to choose from. It doesn't matter whether I choose mashed potatoes and then macaroni and cheese, or macaroni and cheese and then mashed potatoes. It doesn't affect anything. So there are 56 different possible side dishes. Well, it's no wonder I always have a hard time choosing, because there are that many choices. So let's decide whether these are combinations or permutations and then solve them. So if we have 10 students auditioning for 3 different roles in a play, how many ways can the 3 roles be filled? Now this matters because once you attach a person's name to a role, right? So you could have Bob, who is King Lear, but then if Bob gets chosen again, but he's playing somebody else, Arthur, I don't know, those don't go together, but I'm just naming names. Then he's a different role. So this is then a permutation because order matters. So then how many ways can we choose 10 students in groups of 3? And so you run that through and you get 720. Now see, this is what I was talking about with whether order matters or not. We'll look at number 12. That'll be a really good example of what the difference between a permutation and a combination is. So an employee at a pet store needs to catch 5 tetras. We don't care which tetras he catches. So since it doesn't matter, we want combinations. They can be all mixed up. It doesn't matter which one. So you get, you're choosing from 27 and you're choosing them in groups of 5. So I have 27 tetras. I'm choosing them in groups of 5 and order does not matter. So you type that in, 27C5, and you get that there are 80,730 different possible combinations, because that takes out all of your red, blue, green, blue, red, that kind of thing. You take all your repeaters out, and you have your distinctly different groups. So 12, three students are chosen randomly to represent a class of 30. How many different groups can be chosen? It doesn't matter. There's not a vice president and a president and a secretary. They're just representatives. And so this is a combination because we don't care what order they're chosen in. They're not assigned to a specific name or location or position within that group. Okay, so it's a combination. So we're choosing from 30, we're choosing 3 from 30. And so you would type it in like that. So in that case, you get 4,060. Now, that's because we're taking out all those duplicates. Now, what would happen if I ran it and say order did matter? So now what if you have a president, a vice president, and a secretary? So now order does matter. Okay, so what if you do that? Well, then that would be 30P3, right? A permutation of 30 choosing 3, and you would get 24,360. So when you have permutations, it allows those duplicates because now somebody is assigned to a position and it matters. Okay, so that's the difference between what happens when order matters and when order doesn't, because when order doesn't matter, you can take out all those duplicate, but when order does matter, you can use 3 people, but they are in distinctly different orders. They're assigned a distinctly different position, and that makes the number of choices